Welcome back. So I want to talk about in this segment what this term data science actually means. So, you'll see these quotes around the web. So in Fortune magazine, they talk about data science being the hot new gig in tech, and Hal Varian, who was Google's chief economist in the New York Times in 2009, which is a while ago now, talked about statistics being the next sexy job and described it as the ability to take data, to understand it, process it, extract value from it, and communicate it. That's going to be hugely important. Another person who's prolific in thinking and writing in this space is Mike Driscoll, who's the CEO of a company called MetaMarkets, and he talks about there the data science, as it's practiced, is this, has this colloquial view of it, is a blend of Red Bull fueled hacking and espresso inspired statistics. And maybe another quote of his is the data science is the civil engineering of data, whose acolytes possess this practical knowledge as well as a theoretical understanding. And so this balance between pragmatism and theory is something we'll come back to. So another perspective on this that you should be familiar with is this Venn diagram that made the rounds several years ago by Drew Conway. And what his point was that data science is perhaps the mix of three different sort of areas. One is hacking skills, programming expertise. Another is the academic view, the math and statistics knowledge. And then the third that he added is this notion of substantive expertise. And what he meant by this is kind of a deep investment with the data. So if you think about your typical IT shop, they're typically building tools for other people to use to actually analyze the data, but they don't necessarily do the analysis themselves. And a data scientist, in contrast, may be a participant in tool building, but they're going to also sort of dive deeply into the data and do the analysis themselves. And that's one of the ways that I like to interpret Drew's blue bullet here of substantive expertise. Okay, and then he also sort of fills in the gaps between these, talking about that. I'm not sure I'd agree that this is necessarily traditional research, but perhaps it is applying the statistical knowledge to a particular domain is where research comes in, and that some deep theory plus some pragmatic programming makes you a machine learning expert. And then he sort of refers to this as the danger zone, where you sort of know enough about the domain to be dangerous, and you know enough hacking to be dangerous, but you don't know how to ground your analysis in proper theory. And some of my colleagues like to joke that computer scientists don't understand error bars, right? And that's maybe what they're referring to here. Okay. So fine. So what do data scientists actually do? Well, some more quotes here from EMC, a company who acquired a company called Greenplum and recently have a pretty significant initiative in data science, both related to a product called Greenplum as well as other products. So they need to find the nuggets of truth in data and then explain it to business leaders. And I like this, and then explain it to business leaders. Something else we'll come back to that I mentioned previously is that communicating the results is a critical part of this process. It's not just getting the result. Okay. And then another view of this, which is sort of interesting, is that DJ Patil talks about data scientists tend to be hard scientists, maybe coming from a physics background, who have a strong mathematical background and computing skills, and come from a discipline in which survival depends on getting the most from the data. They're really used to sort of torturing the data to extract every last ounce of value out of it. This, DJ has a applied math background, so he's maybe coming from that perspective. So Mike Driscoll also talks about the three sexy skills of data geeks, which are statistics, this thing data munging, and we'll kind of, this funny word munging, and we'll kind of return to this. You'll see a lot of this sort of colloquial language, and I'll give my perspective on what I think that tells us about the state of the world in data science. But what he means by this, as you can imagine, is sort of parsing data and scraping data from the web and converting between different file formats efficiently, and not getting hung up on these the kind of friction that you deal with when you are working with large and heterogeneous data sets. Right? So a data scientist is someone who's very comfortable in that environment and is able to sort of work nimbly even when things aren't very clean. Okay. And then finally, visualization is another sexy skill, right? The ability to communicate the results through visualization. All right. So another quote from Jeffrey Stanton, who teaches a course in data science at Syracuse and is involved in one of the earlier programs in data science, talks about the emerging area of work concerned with the collection, preparation, analysis, visualization, management, and preservation of large collections of information. And I think one thing that's interesting about his perspective is it includes this word preservation. So while the preparation, the analytics and the visualization are the three tenets that you see quite often. It's something that we like in this course as well. Jeffrey goes one step further and talks about preservation. So even after you're done communicating the results, what do you do with the data long term? And that's part of the reason he's got a background in library science and information studies, where they're very concerned with the curation of data. And so that's something we're probably not going to emphasize too much in this course, but it's definitely part of the overall data life cycle, if you will. Okay. So another quote from a thinker in this space is Hilary Mason, the chief scientist at Bitly. And so she says a data scientist is someone who can obtain, scrub, explore, model, and interpret data, blending, hacking, statistics, and machine learning. So we saw that before in Drew Conway's diagram, this blending. And data scientists are not only adept at working with data, but can appreciate data itself as a first-class product. And I think what she's talking about there maybe is being able to organize the data and actually produce something that's usable by other people, right? Okay. So having a quality data resource, a data asset that others can use to answer questions is one of the outputs of data science. And then, she talks about, let's see, scrubbing, and we saw munging on the previous slide. And so you'll see some of these terms. You'll see data jujitsu, people will say. The data scientist that I want to hire is really good at data jujitsu. And we don't, I'll in a couple of segments I'll talk about, or the next segment I think I'll talk about what I think this means. Okay, so to summarize what we've talked about, there's perhaps three overarching tasks involved in data science. And those are, preparing to run some sort of statistical analysis, actually running that statistical analysis, and then interpreting and communicating the results. And this phase here, this preparing to run the model, is where we see all that data munging, cleaning, manipulating, integrating, and so on. All right. So another view that I like to take is that data science is really about data products, producing data products that you may use yourself or that others may use. Okay, and so what do I mean by data products? Well, this could be data-driven applications. So if you think about a spell checker, right, this is not just a piece of code. This is not just a piece of software that does something. This is only enabled by a dictionary of words and a dictionary of misspelled word, actually. Okay, and similarly, a machine translation, where you can type a sentence in French and have it automatically translated into Arabic, relies on not just clever algorithms, but rather an enormous corpus of French text and Arabic text. Okay. A second kind of data product is interactive visualizations. We saw this example with the Google Flu application, and there's a suite of visualizations on the web that I'm not going to show right now that are associated with the global burden of disease. And these are visualizations produced by the Institute for Health Metrics here at the University of Washington. And what I like about it is it's an example of where they've done a lot of research, but then the output was not just a research paper, although they wrote plenty of those as well. It was these interactive visualizations that allowed you to explore the data as well. And so this, I think, captures this notion of producing not just the answer, or not just a paper in perhaps this case, but a data product that is usable by others. Okay. And then finally, another kind of data product might be an online database of some kind that others can actually use to can query and answer their own questions. And so maybe there's not necessarily a visualization component, but the work that goes into producing these things, I would argue, is part of data science. And so this captures some of the enterprise data warehouse work and software and effort, of which there's a lot, and including business intelligence work. And in a couple of segments, I'll try to differentiate those two. Another example of an online database from science as opposed to business is the Sloan Digital Sky Survey, which I'll talk about in more detail in a couple of segments. So again, just to summarize here what's in red, data science is not just about building data products, it rather is about building data products, not just answering the questions once. And what data products are assets, digital assets that empower others to use the data in new ways. And so they may help communicate results. For example, Nate Silver built these maps, or they may empower others to do their own kind of analysis, say with a data warehouse or with a visualization. All right.